Alright, so the first two are asking us to distribute and multiply, but they're also asking a separate question that we need to pay attention to. A lot of students get this one wrong because they don't pay attention to the specifics of the problem. So the first thing we want to do is we're going to distribute and multiply this out. So I go x squared times 3x. So I get 3x cubed. Now notice, I draw a line each time I do a step. A lot of you just draw all the lines, and then we end up missing out on how we can distribute because we miss terms because we drew the lines and then we maybe forget one or two along the way. I use the lines as a checkoff to know, okay, I did x squared minus 2x. I've now done that. And then I move on to the next one. So I get negative 7x times 3x is a negative 21x squared. And I don't draw another line until I had multiplied that out. Then negative 7 times negative 2 is a positive 14x. And then I do the 4, which gives me 12x. And then 4 times negative 2, which gives me a negative 8. Combine your like terms. I always start with my highest exponent, which in this case is a cube. So I have 3x cubed. There is no other x cubed, so that cancels out. I have an x squared and an x squared. Notice when I combine like terms, I only combine the coefficients. My variables do not change. That's the other common mistake students make, is they would write that as a negative 23x to the fourth, which is not correct. Okay, we only add exponents when we multiply. So when I distributed, I added those exponents, but now that I'm just adding, subtracting, you do not change your exponent, you just change your coefficients. Then I like to cross them out to keep track of what I've done. I have 14x and 12x, which is 26x, and then a minus 8. Now, on this one, the question they're asking for is, what is the b? They tried to help out by giving you this up here, ax cubed plus bx squared. They're asking for the b. A lot of students, when we had this problem previously, wrote 23x squared. That is not what they're asking for. They're asking for the b, which is the coefficient, which means the answer is just negative 23. Now 2's the same problem, but this time they're asking for c. So based on what we already did, our c value is what? So a, b, c. So our c is 26. Not 26x, just 26. Alright, number 3. We are multiplying, so we're going to distribute negative 2a times 4a is a negative 8a squared. Negative 2a times negative 3b is a positive 6ab. Notice when the variables are different, I still write them, but it doesn't become like a squared, b squared, or ab squared. It's just a and b. And then b times 4a is 4ab. And then b times negative 3b is a negative 3b squared. Combine like terms, and we get negative 8a squared plus 10ab minus 3b squared, which gives us a as our answer. Okay, number 4, similar to the one we just did, but now it's written out. What does product mean? Multiply. Okay, so when we're doing the product of two binomials, that is the same as what we just saw. So it is 2p minus 3q times, or multiplied by, 3p minus 2q. So now it's a problem we've done before. We just need to recognize the vocabulary of what product means. So then I distribute this out, and we get 6p squared minus 4pq minus 9pq. Notice I always put it in alphabetical order. And then positive 6q. Combine your like terms, and you get 6p squared minus 13pq plus 6q. Sorry, that should be squared, which gives us the answer of D. Alright, 5. This is a good common one that students will make mistakes on. What they'll initially want to do is they just distribute this squared in, and they get 4x squared plus 9, but that is not what that means. What that means is you need to write that out as 2x plus 3 multiplied by 2x plus 3, so that you can then distribute 2x gives you 4x squared. 2x and 3 is 6x, and then 6x, and then 9. Combine your like terms, and you get 4x squared plus 12x plus 9. Okay, so don't forget to distribute. You see a binomial squared, write that out as two binomials, so it helps you remember to distribute. Alright, number 6, we're going to simplify. It's the same idea. You're going to distribute, and we just have an extra term because we have a binomial times a trinomial. So you just go 3x times 2x squared is 6x cubed plus 12x squared plus 9x. And then you do the same thing with the negative 1 minus 2x squared minus 4x minus 3. So I have an x cubed, x squared, and x squared. That gives me 10x squared. 9x and negative 4x is a positive 5x. And then we have our minus 3. So 6x cubed plus 10x squared plus 5x minus 3. Alright, number 7. Same deal. The only thing that's changed is the order. Now, some of you like to do your binomial first. That's totally fine. You would just rewrite this as x minus 10 multiplied by x squared plus x minus 7. I personally don't care. I think it's actually a little easier when it's this way. And you'll see why in a second. So I still distribute. So x squared times x is x cubed. X squared times negative 10 is a negative 10x squared. Then I take the x and distribute it, and we get x squared. X times negative 10, negative 10x, distribute this negative 7. You get negative 7x and positive 70. Now, why I think this is a little easier is we go to combine like terms. There's an x cubed. My like terms are right next to each other, so I don't have to go searching for them. Either way, still looking for those. So negative 10 and 1 gives us a negative 9x squared. Negative 10x and 7x gives us a negative 17x plus 70. So then our answer is, not C, B. Alright, number 8. You had one like this on the quiz, and we made some mistakes on this, which are easily fixable so that we can get it correct on our test. The mistake I'll talk about first, then I'll talk about how to do it correctly. One of the issues students did is they did 5 times 4 is 20. And then they did 5 times 1 is 5. Then they multiplied those two things together to get 100. If we just had the numbers, so you had 5 times 4 times 1, most of you go, oh, that's 5 times 4 is 20 times 1 is 20. Okay, so just because we have variables in there, and you have these parentheses, you only distribute when there's addition and subtraction signs. There is none of those in this problem, so I just multiply everything together. So I multiply my numbers together. So 5 times 4 times 1 is 20. Then I do with my x's. So here I have 4 x's, here I have 3 x's, here I have 4. So multiplying we add, so 4 plus 3 is 7, plus 4 is 11. Then we do with our y's. First one has no y's. We have 1 y there. If there's no exponent, it's a 1. Then we have y squared, so 1 plus 2 is 3. So then that gives us C as our solution there. Hey, 9, which of the following is equivalent? So we're going to distribute that out. X times x is x squared. Then we get negative x, negative 2x, and plus 2. Combine your like terms and you get x squared minus 3x plus 2, which then is D. Hey, 10. The only difficulty in this one is understanding what they're asking. It says rectangle has side lengths x minus 2 and 3x plus 9. Right expression represents the area. How do you find the area of a rectangle? That'd be volume. Length times width times height is 3 dimensions. That's volume. We just want 2, so it'd just be length times width. So my length of 1 is x minus 2. My width would be 3x plus 9. Now this problem is no different than what we've done. We're just going to distribute out, and we get 3x squared plus 9x minus 6x minus 18. Combine like terms. 3x squared plus 3x minus 18 becomes our solution for that one. 11. Multiplying. They changed it. Now we have an x squared in there. It doesn't change what we do. X times 2x squared is a 2x cubed. Alright, so then we distribute our x to the 3, and we get 3x, negative 2, and we get negative 4x squared, and negative 6. Now this time as we go through, I have an x cubed. Then I go to an x squared. And then we have an x. And then we have a constant. So this one we had no like terms to combine. 12. Hey, so we'll multiply. We're going to distribute 9w times 9w is an 18w squared. 9w times a negative 1 is 9. Negative 9w. Then we get positive 9w and a negative 1. Combine your like terms. This time our like terms are exactly the same exception of the sign, so they cancel out. And we are left with, sorry, it should be 81. I put 18, I added. So that is 81w squared minus 1, which is B. Alright, 13. So it says a rectangle is 5 inches longer than it is wide. So think about a rectangle. Some of these problems is not a bad idea to draw out that rectangle. So if we don't know the length of something in math, what do we call it? It's an unknown, and so the way we determine label unknowns is x. So I call this side x. So if the other side is 5 inches longer than it is wide, we're going to take what that width is and add 5 to it. Now we talked about how do you find the area of a rectangle, and we said it is length times width. So then I would go my length, which is x, and times it by width, which is x plus 5. So I get x squared plus 5x, which is then D. 14. Which of these expressions is equivalent to x to the 4th minus 16? So this one is a good question. It's a little more advanced to seeing if we can C, all the complete factorization. So first thing, is there a GCF?
Yes. No.
No number in common, no variable in common, no GCF. So then we go to, do we Xbox, which you can do on this. I would also suggest when you see two terms, start thinking about difference of squares. So on this one, is there a difference between the two terms? Yeah, we have that subtraction sign there. So the question is that you want to answer is, what squares to give you x to the fourth? And then what squares to give you 16? So we get x squared there, and then 4 there. So remember when we do that, we get x squared and 4, x squared and 4. And 4 and x squared and 4, remember, we make one positive, one negative. Now, this is where this one's a little more advanced. Okay, it does say which one is equivalent. As you notice, there is no equivalent answer on here currently. We have a close one at D, but if you notice, D is minus, minus, and we have plus, minus. So this is where the advance comes in. The first one is two terms, but it's a plus sign. The second one is two terms with a minus sign, and we still have a squared. So on this one, we can still do a difference of squares. So then what squares to give us x squared? And what squares to give us 4? 2. Which then means I still have my x squared plus 4, but now I have an x and 2, x and 2, make one positive, one negative, and so that gives us B as our solution there. Okay, so it's just one where you're going to completely factor that out. X squared plus 4, x minus 2, x plus 2. Okay, you won't see one like that on the test, but it's a good one to be aware of, that sometimes there is some extra factoring you may have to do. Similar to a GCF, just because you factor a GCF out does not mean you're done factoring. You may have to do difference of squares or Xbox factoring. So just because you do one step of factoring does not mean you're done. All right, 15. So talking about difference of squares, we have two terms. There is a minus sign, so again, what squares to give us x squared? What squares to give us 25? Bx and 5. So then we get x and 5, x and 5. Make one positive, one negative. Our answer is C. Remember, plus minus doesn't matter which one you put it on, so the order of those two doesn't matter. Okay, 16. Now 16 is a different type of question. They're saying which expression is equivalent. Equivalent does not mean it's completely factored out or completely correct. They're saying, are those equal to each other? Are they equivalent statements? So if we were to do 16 normally, we would find our GCF and factor out a 4, which would leave us with 4 minus x squared. We would do our difference of squares, which then ends with 2 and x, 2 and x, and we get one positive, one negative. Unfortunately, that is not a solution there. So then we have to check the others. So if I just did this without a GCF, what squares to give me 16? Is 4, and what squares to give me 4x squared is 2x. So then we write that out, you get 4 and 2x, 4 and 2x, positive, negative, which then gives us C. So remember, equivalent doesn't necessarily mean fully factored out, it just means, hey, we got to recognize that there are some different ways to write these problems out. Now 17 now talks about the complete factorization. So we need to factor this one completely. We look for our GCF. Our GCF on this is a 2 which leaves us with 4x squared minus 25. Now, I have a difference of squares. So what squares to give us 4x squared? That is 2x. And what squares to give us 25? That is 5. Make one positive, one negative, so then our answer is D. Okay. A lot of students, when you did this type of problem, this one doesn't have it, but sometimes you may see where they have 2x minus 5 and 2x plus 5 without the GCF. That would not be correct. You have to include the GCF in your problem. Okay, 18. So what is a factor? So we're going to factor this. So we have three terms, so we're going to X box. A times C goes on top. In this case, our A is 1 times C, which is negative 12, so we get negative 12. Our B is 1. So what multiplies to negative 12 and adds to 1? We get 4 and negative 3. Do our box. X squared, negative 12, 4x, and negative 3x. Then we look for our GCF. Those have a 4 in common. X squared and negative 3x have an x in common. X squared and 4x have x and negative 3x and 12. Let's say for argument initially we just write 3 down. So if I check this, x times x is x squared. X times 3 is 3x, but it says it's negative 3x. So when you have this negative here, we need to pull that negative out with it. And that gives us x minus 3 times x plus 4. Now as you look at this, you go, well, that answer is not there. Well, they didn't ask for the complete factor of it. They just said, what is a factor? So x minus 3 is not in one of those, but x plus 4 is. So you're just looking for a single factor. So same type of question as factor, but asked slightly different. Look for the specific thing that is asked in the question. 19. So it said, which of the following polynomials has x plus 3 as a factor? So we need to go through and factor these, but some of these we can eliminate. So A has two terms. There is no GCF, and if we look at it, is there a difference on it? X squared plus 9, that is not a subtraction sign between those, so we know that is what we call prime, so that one's not even factorable. Now we look at B, so we have a trinomial. I'm going to do x box, so we have 9 and 3. What multiplies to 9 and adds to 3? Think about it. Things that multiply 9 are 1 and 9, and 3 and 3. Neither of those will add to 3, so that one is prime. So then we're going to do C. A times C is a negative 18, and then our B is 3. That gives me 6 and negative 3, and then we do our box. Now one of the issues students had on your quiz when you did this, when you do the box, your first term, which is 2x squared, goes on the top left, and your last term goes there. A lot of students were putting this negative 18 in there. It is not that. It comes from this negative 9, your original problem. And then we get 6x and negative 3x. Because if you were to add everything in this box, you would get this answer right here. There's 2x squared, 2x squared. 6x and negative 3x is 3x, and then negative 9 is negative 9. So this box completely represents this polynomial there. Then we look for our GCF. We have 3 there. We have an x there. 2x there, and a negative 3 there. So we look at it, there's our x plus 3. And since they only said which one has a factor, we don't even have to check D. Alright, 20. Look for the GCF. So deal with the numbers or the coefficients and then your variables separately. So the GCF between 8 and 10 is going to be 2. Now we deal with our variables, how many does our first variable have? How many x's are in the first one? 6. That's what the exponent means. How many x's are in the second term? 4. So how many total x's do you have between the two? Well, you have 10, but how many do they have in common? Not 2. They have 4 of them in common, right? First one has 6, the other one has 4. If I was someone who's coming to take the most away, I can take away 4 from the second one and 4 from the first one. So we pull out an x to the fourth, which leaves us with, we divide. 8 divided by 2 is 4. When we divide exponents, we subtract. So I get x squared. There's 2 left there. 10 divided by 2 is 5. X to the fourth, and we took 4 x's away, so there's nothing left on that one. So then our answer for that is 2x to the fourth, 4x squared minus 5. 2 terms there left. We do have a subtraction sign, so we think about difference of squares. There is something that squares to give you 4x squared. That's 2x. But then what squares to give you 5? At least no whole number, so that's why that does not work. And so our answer ends up being D. 21. Which of the following quadratics has 2x minus 3 as a factor? Again, we're looking to factor this out. So A is difference of squares. I can go a little quicker through this. So we get 3x minus 2 and 3x plus 2. That is not what we want. So that doesn't help us. B, I'm going to factor out a GCF first, so I get 2, and we're left with 2x squared plus 7x minus 15. Then x, box that amount, and we get negative 30. And 7 is this 10 and negative 3. I do the box. And 2x squared and negative 15. And then 10x and negative 3x. Do the GCF. That gives us 5. That gives us just x. This one gives us 2x. And this one gives us a negative 3, which is what we wanted. There's our 2x minus 3. So then B would be our solution on that one. Hey, 22 is just a straightforward factor of the polynomial. So as you look at that, my x, I get 12 and 7. What multiplies to 12 adds to 7 is 4 and 3. When you do the box with that, you end up with A, x plus 3, x plus 4. Hey, 23 is another factor of the polynomial. I get 4 and negative 5. A lot of students get stuck on this one because they forget the very first factors of 4. Because they go, well, 2 times 2 is 4, but that doesn't add to negative 5. Well, don't forget 1 and 4, and since the bottom term is negative, they're both negative. So don't forget when you're looking for factors, 1 and the number itself works. Put this into our box. You get x squared 4 minus x and minus 4x. And then on this one, as we pull this out, we get 1, we get x, and we get 4. But as we check our work on this one, yeah, x times x is x squared. That's good. X times 4 is 4x, but I have that negative, which means I need to pull that negative out there. Then we go here, 1 times x is x. We have that negative there again, and we need to pull that negative out. So when you have a negative on these boxes here that are on the outer edge, as we work this way or we work up, we need to pull those negatives with us. So we get x minus 1 and x minus 4, which is A. 24, which of the following expressions has x plus 3 as a factor? So when you go through and factor these, I can go fairly quick here. So A, I get negative 6 and 1. That gives me 3 and 2. We do our box. We get x squared negative 6. We get 3x and negative 2. Factor out, we get 3 and x. So there's my x plus 3. So that is one of them. B, there is no GCF, so we'll do our x box on that. And I get 45 when I go A times C, 3 times 15, and 14. We get 9 and 5. There, do our box. You get 3x squared and 15, 9x, 5x. Here I can factor out a 3. Here I can factor out an x. This way we get a 3x, and this way we get a 5. So then we get x plus 3. Oh, that's what we want, so that one works. C, two terms with a plus sign in between. There is no GCF. That is prime, not factorable. As we look at D, what multiplies to 21 and adds to negative 10? You get 7 and 3, but is minus minus. So when we do our x box, you end up getting x minus 7 and x minus 3. So that one doesn't work, which leaves us with only E, but a quick check of that. GCF is 4x on those, so when I factor out my GCF, I get x plus 3 times the 4x. Alright, last page here. Which of the following are correct factorization of that? We've done a bunch of those, so I'm going to just tell you what the factorization is. So when I go 4 times the 9, we get 36. What multiplies to 36 adds to negative 12. And then you do your box from there. You end up with 2x minus 3 times 2x minus 3. So that's C. But then they ask select 2 that applies, so what would be the other correct answer with that? Remember, when it's the same two binomials, we can write that as 2x minus 3 squared. Okay, so don't miss that little one there. 26, which of the following are examples of difference of squares factoring? So difference of squares, remember we get x and 3. X and 3, our terms are the same. The only difference is we have different signs. So A has same terms, different signs. B has same terms, but same signs. C would have the same terms, but same signs again. If we write that out, we look at D. Same terms, but different signs now. One's negative, one is positive, so that one works there. 27. Which of the following expressions are not factorable, which also means they are prime? So as we go through on this one, we know D right away is because we have two terms. There is no GCF. It's a plus sign in between them. When I look at A, I go, what multiplies to 7 and adds to negative 3? There's nothing that does that, so that would be prime as well. Our B is a difference of squares. What squares to give me x squared? Well, that's x. What squares to give me 16? That is 4, so then I can write that out. So that one is factorable, so that doesn't work. As we look at C, there's a GCF of x squared. I don't care what the rest is. As soon as I can find a GCF, that's factorable. So I know that one doesn't work. And let's try E. 3 times negative 11 is a negative 33 and negative 5. So what multiplies to negative 33 and adds to negative 5? So I get 1 and 33, or 3 and 11. Either of those get to negative 5, so then that would be our answer there. Alright, 28, just a straightforward factoring. What adds this, or multiplies to 6 and adds to negative 5? Again, like we talked about before, don't forget your ones and the number itself. So we know one of these is negative, so we're going to get negative 6 and positive 1. So then our answer, once you work that out, is x minus 6 and x plus 1. 29, multiply that over. 3 times 4 is 12 and 8. So that gives us 6 and 2. Draw your box. Notice again that it's 4 that goes in here, not the 12, like some of the mistakes we made on our quiz. Then we get 6x and 2x. My GCF is 2 and x. This way we get 3x and 2. So then our answer and 3x plus 2. Last one, we have two terms. There is a subtraction sign, so difference of squares. What squares to give you x? Well, that's x. What squares to give you 64? That's 8. Make one positive and one negative.